Hey folks, if you have used Stable Diffusion or even Dolly or Midjourney before, you would have discovered that generating images using words only is not easy. You must use precise language that accurately captures the visual attributes you intend to depict, aka prompt engineering. An alternative to describing what you want is to show it. Picture is worth 1,000 words, as they say. We have already covered image to image in this course, and you have likely encountered other techniques that use image prompt as well. Today, I want to talk about one technique of image prompting, and that is IP adapter. What it is, why you need it, and how it can be used. My name is Marco, and welcome to topic 3 of our course on Stable Diffusion and Artificial Intelligence. Adapter models are lightweight, only 22 million parameters, and they are built around a decoupled cross-attention mechanism. The key innovation of IP adapter lies in its ability to work on pre-trained models without requiring significant fine-tuning. This is because additional cross-attention layers handle image features while keeping the pre-trained model parameters fixed. According to its research paper, IP adapter achieves performance comparable to fully fine-tuned models, offering both efficiency and adaptability. Furthermore, IP adapter supports multimodal inputs, letting you combine text and image prompts, which in turn gives you a finer control over the output. So what does this mean in plain English? How is this different from image to image, for instance? Well, let me just give you one usage. Character consistency. Here's a prompt. In a peaceful spring morning, a woman wearing a black shirt is sitting in a park on a bench, and let's say this is your output. If you want now to use this image with a completely different prompt, in a winter evening, woman wearing a thick puffer jacket walks through the snow wearing woolen beanie and a scarf. You will get this kind of output. This is different from everyday image to image, where image and text prompts share the same cross-attention layers. So character consistency is just one application. There are also many others, like style transfer, position transfer. IP adapters are heavily used in generating videos, animations, and so on and so forth. Before we jump into Stable Diffusion, WebUI, and ComfyUI, let me save you frustration by going over adapter models and how they match with visual transformers. As of this recording, your UI will likely match these for you. That wasn't the case when I first started learning this, but it doesn't hurt to know what is actually happening under the hood, so that if you get an error, you understand what file you may be missing. I want to start with visual transformers. I did not introduce transformers before. Just like latent diffusion models or LDMs, transformers are also a neural network. In fact, if you use ChatGPT, that's what T in GPT stands for, Generative Pre-trained Transformer, or GPT. Now, visual transformer is transformer applied to image processing. If you're familiar with Blip, think of it as something similar, except it doesn't convert images all the way to natural language. Instead, it represents the image as tokens that preserve the image's structural information. Think of these as eyes of the IP adapter. There are two clip vision transformers you should be aware of, and they must be correctly matched with each IP adapter model. Clip with H, I'll just call it with H for short, and clip with big G, or I'm just going to call it with G. With G is a larger file size than with H, so I remember it as G for gigantic and H for huge. Letters probably don't mean that, but in my mind that's just easy way to remember it. And now that we've done that, let's look at the IP adapter models. For models that are for use with Stable Diffusion 1.5, we have a standard one. We have Light, same as standard, more compatible with text prompt. With G version uses with G transformer, Plus, closer to the reference image and standard, and then Plus Face, uses cropped image as condition. For SDXL, same pattern. We have a standard. With H, uses with H transformer, Plus Face. I have excluded Face ID models from this video, just for the time being. They're a little bit more involved, and I have also excluded community-based models, so there is no full face, there is no composition and all the other models that are out there that you can in fact download. Now, how do these match with transformers? You can use a reference table to, if you ever forget. Personally, I'm too lazy for that, and I'm also not a fan of route memorization, so let me share a pattern with you here. All Stable Diffusion 1.5 models use with H unless it says says otherwise. Likewise, all SDXL models use with.g unless it says otherwise. That's kind of the way I've remembered it. And of course, I'm also in the process of putting together a reference table, so you can always look it up either on my GitHub or look it up on someone else's if it helps. Now, why is there so much confusion? Why is it so complicated? Essentially, what happened is, even though it's smaller of the two, with.h is actually a newer version. It's kind of counterintuitive. Our minds are trained to think bigger is better. SDXL is bigger, therefore better than Stable Diffusion 1.5. In this case, however, it's not quite the case. So although SDXL development started with.g, what happened was experimental results have shown that using the smaller with.h brings no significant drop in performance. Smaller model means less memory used during inference. And lastly, developers claim that there are also advantages in terms of SDXL adapter training. I don't know much about this, but apparently, according to the official repository, with.h allows for faster and more efficient two-stage training strategy. What I do is they train adapter at a lower resolution first, 512 pixels, before fine-tuning it at 1024, and that comes without sacrificing image quality. And lastly, when it comes to best practice, it all depends on what you're trying to accomplish and what inputs you use. For image-only prompt, if you're just trying to get variations of an image, you may wish to keep the strength at the maximum. After all, you want your output to be heavily influenced by the image prompt. Reducing the strength will lead to more diverse, but also less consistent images. It's also possible to combine image prompt and text prompt, giving you essentially the best of both worlds. Technical term for this is multimodal generation. For mixed text and image prompts, adjusting the scale to 0.5 usually provides the best results, but this will again vary depending on what you're trying to do. And that's it from me. My next video will be the computer lab where we'll actually put this in practice in both Stable Diffusion WebUI and ComfyUI. So, class dismissed.